Hey guys, back. I know I say that a few times, but I'm actually back. Had a couple people reach out to me and say they really appreciated what I was doing with these videos, so, felt good. Good times like that. So, as long as I'm making a difference, I'll go ahead and make some videos. So I was given a couple questions, some topics to cover, and I'm gonna go ahead and cover one of those right now. And the one that I wanna talk to today is testing. And testing specifically about like those contractual things. And here's the reason why. I know I mentioned in a previous video that, civil engineering and geotechnical engineering is the most inexact form of engineering that exists because soil profiles can change several times over a single property, over a specific area, one house, one stretch of roadway, whatever it is you're working on, the soil profile can change, whether it's the density, cut versus fill, the consolidation, really everything can change, right? And so it's really an exact form of science. That being said, when a contractor comes out and looks at your house and they're providing you a proposal for a specific schedule of work in order to level out or stabilize your structure, there's a lot of information that really just can't be verified until later on in the process, right? No matter how much investigation I do, unless I go to the city and pull plans or you have as-built drawings or something that show how a foundation was actually constructed, I don't know how deep your footing is by the home, whether it's got the proper rebar or the spacing or the reinforcement. I don't know if it's seismically strapped, although that's something I can look at if it's inside of a crawl space. I don't know if it's got little mini piles that are along the footing along the way, There's just a lot of information that you don't know until you dive into it. Same thing with the soil itself. I can design a helical pier based off of what I assume the soil properties and the structural properties can be, and probably be pretty relatively accurate. But, if you make your proposal based on that, and then either you do soils testing or you get into the job itself and the soil is absolute muck, or if it's too stiff, so the helical screw anchor won't actually get through. If you need a bigger screw anchor, more blades, or different design depth, or a different torque pressure, push piers that end up going 80, 90, 100 feet deep, everything gets skewed without having that information up front. Now, 98% of all contracts are going to cover this, and a lot of contractors will not put the little clause, well, they're not going to point out the clause that's in their contract about it, but also probably 90% of the time you can go apples for apples by getting contractors to give you their bids and then making sure that everyone has the same depth clauses, footing clauses, and all that other fun stuff. That being said, why do they charge something like that? If I've got a house, if I assume it's built to a regular building code, I can assume that your footing, which that's horrible, I'm sorry, but I can assume your footing is 12 inches, 12 inches here, 6 inches here, right? And then soil, that's 12 there. 12.6, 12.6, that's the first rule. If you add a second story to the home, then that all builds up by 2.146. So I can make assumptions about your footing size here. If I have to dig down 16 inches, maybe 18 inches, not a big deal, but if they start digging down and they find out that you got these caissons underneath here and that's 4 feet thick, and that's what they have to do, that changes the design of the pier if it's a helical pile, because it's a lot of extra weight. It changes probably how deep the pier is going to go if it's a push pier, because push pier is end bearing and it relies on the weight of the structure. You add all of that weight to it, then it's more than likely going to go deeper. And it's a lot more labor, right? If I got to dig down 4 feet versus the 12 inches that I had originally thought, it's a lot more labor. So it's understandable why people would write things like this into the contract. It makes sense. Matter of fact, I got a project that I have going on right now where we've got a slope leading up to a structure, and it's 2 stories. Wow, my drawing got worse. Anyway, slope leading up here, and they've got a footing that is 7 feet down on the descending slope side. And then you would guess with something like this, the footing should jut inward, right? Because the downward pressure of the soil helps resist the tilting and blah, 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 but it's not. It goes out this way by another 6 feet, which creates a moment here where it's actually more likely to topple. So they're dealing with that as an entirely separate issue, but trying to lift all of this soil and all the skin friction of this soil on this side and trying to pick all of that up using polyurethane foam is wild. So they're actually digging down for us so we have better exposure to drive our tubes right here and inject under here in order to get that lift, and we're way more likely to get the lift. Haven't done the job yet, but you can see that's a complication. For us, we would have done the injections from the surface on the outside of the structure, but now they're digging down 7 feet to expose this wild footing that they have out there, right? And that's just nothing that nobody could have anticipated when doing the estimating portion of this process. So it's pretty wild. So what kind of testing is gonna be done? Now, again, always get a geotech report. Get a geotech engineer to do his thing. He's gonna do split spoon sampling or core sampling. He's gonna get the samples that he wants to draw in situ tests of what the soils look like around the property. And he's gonna be able to profile the soil more accurately so that the soil itself is profiled. At that time, you have a good opportunity to take a look at the foundation of the structure as well. What many of the piering contractors offer now is a test pier. And I am a huge proponent of this, whether it's a helical pile or a push pile. And so if I've got, a wing of the home and it's got piers proposed along this section, typically you'll take a pier that has the area of greatest settlement closest to a corner or near a fireplace and on a descending slope side, right? Typically one of these two piers would be most ideal for you, assuming the greatest settlement was right here, but that'd be most ideal for a test pier. And a test pier is exactly what it sounds like. They're just gonna install one of those piers. Usually a small team that comes out in order to install the piers, but what does that do for me? So when I've got a footing, right, and we've got some assumptions, again, 12 inches, you got soil, that's 2 inches, probably, and you got 6 inches, 6 inches, right, that's what I'm assuming. So what they'll come is they'll go in and they'll dig all of this out and they'll expose to the underside. They'll expose to the underside of the footing. They'll cut this section out and they'll actually install the pier bracket if it's a push pier. If it's a push pier, they'll install the pier bracket. If it's a helical pile, they're just gonna drive down and hit their torque down at this depth. And what they're doing with this installation is verifying what the torque pressure, so I'm talking helical piers, they're verifying what the torque pressure is as they're driving this thing down, a minimum of 10 feet, because that's what the building code requires, minimum of 10 feet, and checking their torque pressures and making sure that the configuration works out, making sure they can hit the target torque and at about what depths that they do hit those target torques at. And what that takes away is the depth clause, right? The torque pressure, having to change the design of your helical pier or something like that based off of existing soil conditions. Or with a push pier, they'll actually install that bracket and then they'll push the one pier down. And if the push pier goes down 80 feet and contractually you're responsible for 20 feet and then X amount of dollars for everything past there, well, it's a different conversation, right? I mean, if you're going to triple the cost of your foundation repair, it becomes an issue. So the push pier is good. And at the same time, the good companies come out with little rebar scanners and they check to see what the rebar placement inside the footing looks like. Probably should have changed the colors, sorry. But they check out like the rebar on the inside to make sure you have proper reinforcement. And why is all of this important? I just talked about like the depths, right? If the piers go 80 feet versus 20, or if the helical pier design needs to be changed by design of the soils conditions, but also checking the rebar inside the footing and the sizes of the footing. This is not 4 feet deep. It's not 0 feet deep, right? It's not a 4-inch slab just sitting on top of soil, in which case they might have to brace it with like steel framing on the underside or L brackets or steel tubing or whatever their method is to handle that. But that steel costs money. And not only that, instead of digging a 3x3 hole like this, now they have to trench between it in order to install the steel underneath the bracket and then put the piers attaching to the steel. So that changes all of your labor and your material costs. This ends up being a change order. This happens often, remember, with sliders, like big sliding windows, anything over 6 or 7 feet or anything that causes the spacing of those piers to be wider than the engineer would expect typically has to be braced with steel to prevent the bending and cracking and ultimate failing of the footing in between that slider or anything else like that. So this is a very normal practice, but it's always nice to know this up front So even if you get the geotech report, if the civil engineer comes out and he tests, he does a boring here, and he does a boring here, and he does some boring out here in the middle of no man's land to get like a general profile, whatever he does, you want to make sure still that you check out the footing and the conditions and everything else like that. So I always encourage still the contractors come out and install a test pier when doing foundation underpinning for something like that. Now, that's to address like push piers, helical piers, concentrically loaded piers, which I'll talk about later in a different video. I think I haven't talked about that yet. Concentrically loaded piers and things like that. What about the polyurethane? Like, obviously, all of our numbers are based off of what? 2,300 pounds of polymer. Well, I can't look at a house and say, hey, I could get $80,000 of geotechnical engineering testing, and I'll never, ever be able to say this project will take 1,263 pounds of foam. Never going to happen. It's not about soil replacement, which you get with more like lightweight cellular concrete stuff. It's about getting the polymer into the ground and having the proper densities, compressive strengths, and everything else to not only stabilize the area, but facilitate that lift. Now, if you got, the footing of the home and the polymer is going around and around, and it depends on the soil below. If you're specifically lifting the project, you'll build a platform of polymer under, and then you'll shoot here in order to lift up, and it gives you better ideas, but that changes your injection pattern. So you're never ever gonna know how many pounds of polymer specifically people are proposing. This also changes based off of 5-foot spacing and 4-foot spacing, which a lot of 3-foot spacing, if you're doing like cutoff walls and things like that. Huge debate argument between the 5-foot and 4-foot spacing. 5-foot can work, does work as far as lifting goes. As far as stabilization, all the science and everything is at 4-foot spacing, because it was developed in Finland at 1.2 meters with the spacing. It's 4 feet, not 5. But 5 works, it'll lift your house. So, I mean, if you don't care, no big deal. And if you maintain proper drainage practices and all that fun stuff, then that's fine. That will probably solve the problem. I just know at 4-foot spacing, I myself, to date, have never had an actual return trip that we were responsible for. Anyway, so as far as judging the polymer, the main thing that's going to change the amount of pounds of foam that go in is the soil density, the soil type, and soil characteristics like that, right? So I'm going to make a different video on reading engineering reports so we can talk about plasticity and expansion index and hillside slippage and liquefaction and blah, blah, blah. That'll be a whole different thing. I'm talking specifically to the contract that you have with the contractor. How do we try and isolate, mitigate, or solidify this 2,300 pounds? Just the number I'm using as an estimate. And you can do that with some DCP testing, which is dynamic cone penetrometer testing, which I think I'm going to mention that in another video. If not, I'll make a new video about it. But those blow counts are convertible into end blows, which is what your SPTs are. So geotechs and civils kind of like this. It's just a density test though, so it doesn't actually extract a sample, but different story. But this gives us relative soil density. So, I mean, if we start hammering through and your soil is super, super, super stiff, we're probably going to use less than 2,300 pounds of polymer, right? The worst project I ever looked at was in San Mateo, and I mean, we would put the DCP hammer onto the rods and it would just sink. We hadn't turned the machine on yet, and it would just sink into the ground. And it did that for the first 24 feet. It's not even one blow for 24 feet. It was way more than 2,300 pounds of polymer. 2,300, there's reason why the estimates are what they are. Every company has their own way of doing things and estimating and doing all that fun stuff. Lots of calcs that you can run to get there, but ultimately it's still going to rely on the soil. So to solidify your information you're looking for, doing testing with the DCP or dynamic cone penetrometer, vast majority of geopolymer companies have a DCP now. Most people use the Pagani DPM 1020, which is the one that I'm talking about right now. That you can convert into the end blows, and it works out real well, right? So once again, it's really just, oh, and by the way, yeah, if this DCP goes down 20 feet without turning the machine on, then if my estimate was to, under your footing, have 1 and 2 depths, which is what the vast majority of contractors will assume at the very beginning is 2 depths, of injection. Well, you're going down 20 feet, suddenly you're looking at like 4 or 5 depths of injection, which vastly changes your contract, right? It's just time, material, labor, all that fun stuff. And it's nothing the contractor can know until either you start the job or you do this testing, be it test pier or DCP, right? So there's a little exploratory testing that has to be done, even micro piles, mini piles, caissons, and stuff like that. You still need to actually verify the footing sizes and dimensions, which you're gonna do anyway when you start the job. But once again, you'll get hit with a massive change order if the footing has a whole lot of issues that they couldn't possibly know before they jump into it. So they call it destructive testing or invasive testing when they actually expose the footing and take a look at stuff like that. But it's very, very, very highly recommended that you guys get the proper testing done to solidify your contract. Just take all the question marks out of it. The contractor has less surprises. You have to have less uncomfortable conversations, given that you know this information up front and everybody is capable of doing this. So that's it. That's all I got for you today. Good to see you guys again. Good to be back, I guess. Looking forward to making a whole lot more videos. Hold me to task. If I don't do it, you let me know. In any case, please like, subscribe, do all the things. I'm not super commercially. Thank you guys so much again. I appreciate you.